Good morning, Tehmina Khan is here in TKMaths S1. In today's video, I will explain to you the concept of a stationary point and nature of a stationary point, which is a part of the syllabus of differentiation topic. It is A-level mathematics P1. It is also a concept required for O-level Add Maths. So I'll put the same video up there as well for students who are taking additional mathematics. So the question I've picked up is from June 16, variant 1.3, question 5, and the code is 9709. So let's begin with the question. Now, in this question, the equation of the curve is given to you, and we have to find out the value of x at which the curve has a stationary point, and then we have to determine the nature. So before I begin solving, let's see a concept or visualize a concept. The sketch I will show you is not actually the sketch of this curve. I've just picked it up. So to explain the concept basically to you, right? So if any curve is given to you, similarly, when you will see this curve, what is the stationary point? Mean where the curve is taking a turn here, or sorry, not turn, because all stationary points are not turning point. So where the gradient is 0 basically, right? So if you draw a gradient here, it will be 0. If you draw a gradient here, it will be 0. So these 2 points are your stationary points. And then you can see it is maximum value and it is minimum value curve. So similarly, you have to find out the points on this curve where the gradient is 0 and you have to find out either it is maximum or minimum at that point. And that you find out with the help of this understanding, if you know. You just check double derivative if it is negative. Then you say it is a maximum value curve. If it is positive, you said it is minimum, right? So let's just start with the actual question. This was the visualization of the concept of a stationary point and nature of a stationary point with the help of another graph. Okay, so now let's see. So first thing is we will differentiate the equation, and then we will substitute dy over dx equals to 0. You know how to differentiate it. Differentiation of 8x is 8. This is a composite function. So minus 1 will come here as a multiplier, as it is. Subtract the power by 1 and then multiply by the differentiation of this. By the way, I'm giving the link of the videos, introductory lesson of differentiation, in which I have explained this concept in detail, so you can see it there. So after differentiation, now you got the gradient function, right? When you first differentiate it, you get a gradient function of this curve. Now, if you put it 0, because at a stationary point, the gradient is 0, you will get the value of the x, correct? And that value of x, when you will plug in back here, you will get the value of y, which is not the requirement of this question, because question is saying only find the values of x, not find the points at which the curve has a stationary point. Question is saying find the values of x at which the curve has a stationary point. So that's why when I will put it 0 here and solve it, I will get the values of x. Okay. So it's simple algebra cross multiplication, and then I am dividing this equation by 2. So I got here 4 and 1 here, and I open the bracket, and then I'm simplifying it. Simple algebra. I'm sure you are comfortable with this. So after doing Milton breakup or factorization, you get the values of x, and what is that? 3 upon 4 and 1 upon 4. So you got the first part of the question correct. You got the values of x at which you have a stationary point, at which the gradient is 0. Now we have to find that at these points, at these values of x, the curve is maximum or minimum. So now we will differentiate this first derivative once again, because the second derivative give us the nature, maximum or minimum. So now I'm differentiating it again. So before differentiating, I'm taking this up in the numerator. It's easy to differentiate in this way. And then differentiation of 8 will become 0. The same procedure, minus 2 will come here, right? Minus 2 will be subtracted by 1 and then multiply by the differentiation of this. which is 2, because the differentiation of this is 2 minus 0. Minus 0 we don't write. So now this gives us the function for the double derivative. So now this function will help us to find the nature on those two values of x. Okay. So let's substitute x equals to 3 upon 4 in this equation, and then x is equals to 1 upon 4. We will see the answer comes positive or negative. And by the way, after showing one-time substitution, you can just use straight away a calculator. You don't need to show further cancellation on the paper. That is not the requirement. Yes, substitution of the values in the function in which you are using it is important, so you need to show that. So after using calculator, you got here that answer of this is coming 64, which is positive, greater than 0. And when you solve this part, answer is coming minus 64, which is less than 0. So what did you conclude from here before I show you? That at x equals to 3 upon 4, the curve will be, when it is positive, double derivative, what it is? Minimum value, right? So you can say that at x equals to 3 upon 4, it will be minimum value, and at it will be x equals to 1 upon 4, sorry, 3 upon 4 and 1 upon 4. So it will be maximum value, right? So this is what was the requirement of the question, to tell the nature of the curve, either it will be minimum or maximum. So you have identified here. Thank you very much for watching this video. There are links of the other videos for other concepts like rate of change, equation of tangent in the description given below or on my blog address. So you can visit it and see it. Thank you very much for watching. Please share it with your friends and with your loved ones, so they will also learn it from here. Take care. Allah Hafiz.